so we are going to finish the notes from yesterday. The first thing we're going to talk about are horizontal tangents. On the graph below, sketch any places where there are horizontal tangents. Any ideas?
No. 1. 12.
Okay, at about
Negative
here.
5.
Everyone agree with that?
Right.
Here?
Yes. No, yes.
And where else?
On the other.
Okay. So, horizontal tangents appear to occur when the curve is at a maximum or minimum, right? Seems like it. What is the slope of those? Okay, so what would the derivative be there? 0. So I can estimate where these fall. It definitely looks like one's at 0. That one looks to me like it's at 1 point something. Does everyone agree with that? And negative 1 point something? Maybe negative 2. I don't know. We'll find out. Okay. We're going to find out exactly where they are by using calculus. Have you ever been able to find a maximum or minimum by hand before? Not unless it was a parabola, and most of you don't remember that formula either. The negative b over 2a thing. Minus 8x squared. Do what? Oh, yeah? Sorry. Did I hurt your feelings? Sounds like I did. It sounds like you're a little bitter about this.
We didn't remember it, but Pax obviously did.
Pax is 4x cubed minus 16x.
Okay, any questions so far? Can I set that equal to 0?
Yes.
Factor? Good.
Oh.
X plus 2x minus 2?
Yes.
So, where do those horizontal tangents fall at?
There's 0, negative 4, 4.
No question about it. I now know exactly where those horizontal tangents fall at. I now know exactly where those maximums and minimums fall. I've never been able to do that by hand before. Pretty nifty. Did it take me very long to do that?
But if it was a decimal, would it? Okay, you're talking about 1 point.
It depends. If it was factorable, it'd be easy. If not, if you had to use a quadratic formula, it may be a little tougher. Okay, any questions about that one? Okay, the next thing we're going to talk about is higher order derivatives. You probably saw on your homework some weird notation with things like d squared y, d, what in the world was that, right? Well, we're about to find out. Well, if you did a derivative on it, you're on the right track. You're not done, but you're on the right track. Yeah. So, the derivative of f is called f prime of x in Newton notation. The derivative of f prime is called f double prime. And it's just the second derivative. It's just the derivative of the derivative. I could do a derivative again. I could do them as many times as I want to. Those are called higher order derivatives. And I hear the first question is, why would you ever want to do that? We will do applications later, but just for those of you who are interested right now and have to know where you would ever use them, remember the first derivative is a slope, right? So say we're in meters per second, and that's my slope.
20.
What would the slope of the slope be? meters per second, which is meters per second squared, which is acceleration. You physics people? There's actually a real application. We'll talk. It's just the second derivative. Okay, now the biggest thing you need to know, because the hardest part about this is the notation, because it's just taking more derivatives of derivatives. It's just continuing what you did yesterday. So the hardest thing is the notation and knowing what notation means what. And there are about 6 notations that we could use for a higher order derivative. So I just want to walk you through notation. If you're using the tick mark notation, which is called the prime notation, that's what Newton used, you do 1 tick mark for the first derivative, 2 tick marks for the second derivative, 3 tick marks for the third derivative, but after that, then you do a number 4, because after 3 tick marks, we feel like we might start losing them. So we do the number 4 for the fourth derivative and anything after that. Leibniz, the other guy who came up with calculus at the same time, used the delta y over delta x notation. You remember us talking about that, the change in y over change in x? In his notation, it's the 6th change in y over the change in x 6 times. So that's the notation for the 6th derivative. Looks a little strange, but that's the notation in Leibniz notation.
Do it 6 times?
If this were the question, you would do the derivative 6 times, yes.
Do we have to do that on homework?
I don't know. Yeah. I know there's a 3. I saw 3. So I want you to write down all of these notations. They all mean 6th derivative. They all mean the same thing. They mean the 6th derivative. We will do some examples.
Is there a shorter way of doing this?
No, but it won't take you that. I mean, if it's a polynomial, it's pretty. Now, are you often going to have to do 6 derivatives? Probably not. Maybe on the first homework on this, but after that. Now, the second derivative is quite important, as you can tell by the physics application. But after the second derivative, the applications aren't as important. Then you could shortcut it, because you know it's... But for the most part, you'll just have to do a bunch of derivatives.
Hey, that's not so
Y'all do know I'm recording, right? I mean, I'm okay with it.
Oh, Lord.
I have 2 equations here. This says x to the negative 2, by the way. And I want to find the 5th derivative. All the way down to the 5th derivative of each one.
0.
Hold on. You will be fine. This is not hard, I promise. Not really. This doesn't take you as long to do 5 derivatives on that function at the top on the left as it took you yesterday to do 1 derivative of the same thing.
So you go like
You could. I'll have to remember what we just replaced yesterday before you whine about this. This is not bad. So what's the first derivative, by the way, if you can't see that? It is 3x cubed.
Not x squared.
Minus 4? Any questions?
Well, I thought we were doing it to the fifth.
Well, that was the first.
Okay.
Yeah.
Alright, guys.
What's the next one?
18.
What's the third one?
0. No.
18.
18. I'm sorry.
18.
Good. Anything after that would be 0.
What is he?
Okay.
Oh, I forget. I guess.
Okay.
Derivative of.
Of the derivative.
Whoa! Clicked.
Do we have to show all that work?
Well, if this were the question, yes, because it asked you to find all 5.
Oh.
But if it just said fifth derivative, then no. If it were truly a cubic, you could know the fifth derivative was going to be 0. Okay, the next one. This says x to the negative 2
Negative 2.
minus 2x plus 500. Is this one ever going to go away?
No.
Why not?
It's already past 0.
It's already negative, so when I subtract from those negative exponents, they're going to be bigger negatives, right? So it's just going to keep going.
Negative 3. Negative 2x. Negative 3. Minus 2.
Okay, any questions about that?
6x. Negative 4.
6x minus 4. Or negative 4, my bad.
Good.
24. Negative 24.
Negative 24. Minus 5.
What do you mean negative 5?
Negative 5.
Come on.
Melton.
120 x negative 6.
Great counter, by the way.
Negative 6x.
Negative 720.
Yep, 700.
X always to the first.
Does anyone not know how that we're getting these? Any questions? Okay. Did you maybe overcomplicate that before we started?
Yeah.
Alright. I'm going to do some examples. What do I need to do first?
Make it a fraction.
Rewrite it. 2/5 x to the what?
Negative 5.
Why would I want to rewrite it? So I can use the power rule, right? I can only use the power rule if I have something that looks like a polynomial. It's not actually a polynomial. Polynomials don't have negative powers, but I want it to look like a polynomial. So the derivative is
Negative 2. X minus 6. Negative 6.
okay. Any questions about that?
2/5 x. Negative
2/5. Where is the x if it's on the top?
It's on the side.
Right. It's not to the negative 1 because it's just to the first power, right? So what's the derivative of that? 2/5. Find the slope of the graph of x to the 5th at 2. Well, what's that saying?
Find the derivative and plug in 2.
Find the derivative and plug in 2.
X to the 4th. 5x to the 4th, sorry.
The notation in Newton notation would be f prime of 2. The notation in Leibniz notation would be the derivative of f of x with respect to x at x equals 2. I do want to show you that notation. You'll see it later, but this little bar there, x equals 2, means such that x equals 2, and so that little bar is the notation you would use there. 2 to the 4th is 16 and 8. Good. 16 times 5 is 80.
Six x 2 minus 8 x 1 plus 3.
Okay, any questions about those?
The one above it, so you just look at it too.
Yeah, because I want the slope of the graph, which is the derivative, at x equals 2.
Why'd you write that thing on the left?
That's just a different notation. I was just showing you notation. Okay.
Oh my gosh.
Oh, geez.
Do I have a rule for sine of x?
No. Oh, no.
So, if I don't have a rule, then I must go back to the definition of derivative.
X plus h minus sine of x the whole bridge.
Somehow I've got it. That's a 0 over 0. Does everyone agree? Nasty. Plug in 0 for h. I get sine of x minus sine of x, which is 0 over 0. So, at first glance, I am stuck. Any ideas? I hope to only have to do this one time. Because after I do this one time, what am I probably going to do to it? Memorize the shortcut, right?
You need to square the top of
Probably won't.
The S to H is just 8 x 1x.
Really quick, is there a way to break up the x plus h in a sine function?
Yes.
Is there an identity for that?
Make it
Sum and difference, and what is that identity? You have a trig helper that could help you. But it's not sine of h. No, you'll like me.
it's plus. Now.
I'm going to group the two things with a sine of x together and factor out a sine of x in those two things. Okay, so I grouped this thing with this thing and factored out a sine.
Oh, you forgot.
What did I forget?
I forgot.
Okay, for some crazy reason, I want to split those up. As h approaches 0, does this limit look familiar to you?
Yes.
What is that limit that you have memorized? 0. What's 0 times anything? 0. What about this limit here? 1. And the cosine of x times 1 is just cosine of x. So it appears that the derivative of sine of x, thank you, is cosine of x. So you have one of two options. You can redo that limit, or you could never redo that limit and memorize that the derivative of sine of x is cosine of x. That's what I would do. The derivative of, so you see where it comes from. We could do it the long way. I would rather not. So the derivative of sine of x is cosine of x. Anyone who is intelligent saw that that was a lot of work, and I don't ever want to do that again. Right?
Right.
So we're going to memorize
What if they ask you to this? Then will you?
I got to test.
it. You will. And I am going to tell you that the derivative of cosine is negative sine. You could do the same limit process and get there, but I'm just going to tell you that it's negative cosine.
You're just gonna have to work that out in test.
No.
So what's the derivative of a negative sine?
Well, just take the derivative of sine, and there's a negative sitting in front.
So that's cosine.
So, these two derivatives we're going to memorize. You might be wondering what your next mastery exam entails. It's a bunch of memorization of derivative rules. So that's what's going to be on your next one. It is memorize. I don't know if it's easy, but you got to memorize. Okay, I think this page number's wrong. I think this is from a different textbook, from a different school. Okay, but anyway, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. I'm just going to memorize that because I don't ever want to do that limit again. So,
Do it 3 times.
find the third derivative of sine of x.
Cosine.
Oh, no. It's negative cosine of x.
Okay, any questions about how I got the first derivative? How did I get it?
You just did it.
Because I memorized it. And then what's the derivative of cosine? And I know that because I have it memorized.
And the negative side is negative cosine.
The negative's just going to stay sitting out in front, right?
Right.
And the derivative of sine is cosine.
Where does is it going to ask us about it?
Maybe, but not today. We're probably going to use sine divided by cosine and work from there. But the problem is we don't have a rule for division yet. So we're stuck for today. So no tangent for today. Okay, first derivative. This is not involving sine and cosine, but hey, now we know sine and cosine derivatives. It's fun.
14 x 6
Minus 5
x 4.
So those of you who are a little shaky on this yesterday, how are we feeling today?
Feel good. Better.
Power rule coming together?
84x 5 minus 20x 3. 420x 4 minus 60x 6. 1680x 3.
Hold on. My pen doesn't work that fast.
Drew can double any number.
I can double any number. Unless
It's probably like
Just give him a number.
in practice for 8 hours. Just to figure me able to show off.
that's what I do. Just go home.
Give him a
And beatbox.
Please beatbox one more time.
Any questions so far?
No, and then it's 120 at the end. And whatever 3 times.
If someone grabs a
So 8 times 3 is 24.
49, 5, 20,040.
18. Any questions about that?
I started this before you said.
I don't know how many examples you need to see. We'll do a couple more.
Yeah, just do these last two.
Differentiate.
Ah,
What's that word mean?
I don't know.
It means separate.
Find the derivative.
Oh,
Find the derivative.
that's just another word for derivative.
It is the verb form.
They must start with D,
Like
right?
find the derivative,
So
differentiate
derivative.
is the noun.
Oh,
What's this one?
That's negative.
So it'd be plus 2 sine of x. Why is it plus 2? The derivative of cosine is negative sine, and then the negative times the negative makes a plus.
We get to watch the video that you're going to show us.
We might. I think it's a Christmas one because I teach this. I don't remember. Maybe not. It's been a while. Have I done any differentiating yet? One of the mistakes people will make on finding derivatives is they will do an algebra step and think they've done a derivative step. Right? I didn't do a derivative yet, so make sure you label what you did. I didn't do anything yet. I just rewrote f of x to make the derivative easier.
X.
And if you want to rewrite that, you can. You don't have to. It's up to you. In calculus, we take equivalent answers. You may have to match a multiple choice answer where it says negative 1 over x squared, but you don't have to write it that way. Horizontal tangent line. Horizontal tangent line. How do I find horizontal tangents? Find the zeros of the derivative. So the derivative is 1. What's the derivative of that? And I want to set that equal to 0. Is that something I can do?
Potentially.
Good. And when does cosine equal negative 1? Pi, right? Remember, cosine is the x value. It's negative 1 back there. Any questions about that one? Now, quick question. It says find when the graph has a horizontal tangent line, right? Another question AP sometimes asks is find the horizontal tangent line. Just a mental note, this is when there's a horizontal tangent. How would you find what it is? What does a horizontal line look like? Oops. It's a y equals, right? The slope is always 0, right? It's y equals something. Agreed? Y equals what? What number? What? Plug x in. Where would you plug x in? The original. Why the original? Isn't that how you find y? At that x? And so the horizontal tangent line will be y equals whatever you get when you plug in pi. What's sine of pi? 0. So it's actually pi. It wouldn't always be, but the y value when x is pi is also pi. So the horizontal tangent line is y equals pi. I'm going to go ahead and put pi plus sine is 0 just so you know it's not, which is y equals pi. So you know it's not the same just because they're, I kind of wish it hadn't been the same, but that's okay. We'll be okay. Alright, I think we're good on those. Are we good on those? What about division? Do we need to see a division one again?
Just divide.
Divide first. So 3x squared divided by x squared. What is 3x? It's just 3. Minus 2 over x. But what do I want to write that as?
2x negative 1.
Plus.
7x negative 2.
Okay, so that's the original function, and then I take derivatives. Any questions about that one?
Next one.
And remember, I haven't actually done any derivatives, but now I can very easily. Any questions about those? Okay, I knew that there was a chance this would take me 2 days to teach, and so because of that, I skipped the homework. I am going to give you that homework. It's actually a derivative the long way homework. It's got 3 problems on it, though. So I'm going to give you that homework today. Last derivatives along the way, besides on the test. Anyway, and then you have your other homework. So both of those, you have, what time do we get out of here?
5.
So you have 10 minutes left in class to work on both of those. Do we feel like tonight's homework is easy now?